leaders, today's lesson is 3.2 magnetism, and in this lesson I feel like we're going to combine a lot of what we've learned so far in chapter 1 and 2 of this unit. We talked a lot about potential energy in the system and how magnets can store potential energy and trying to figure out how we can get the most potential energy. In chapter 2 we talked a lot about moving magnets with and against their magnetic field. So with attracting magnets, you know, what are they already doing? What do they want to do? Are we moving them with, or are we moving them against if we move closer or further away? And then we're going to add in a little bit of what we've learned so far in chapter 3, talking about strength of magnets. And we're also going to kind of tie in a new concept of distance between magnets and being able to compare the distance between magnets. So a lot that we're throwing together in this lesson today. Okay, so your learning targets: I can relate how the strength of magnets affects the potential energy of a magnetic system, and I can relate how the distance between two magnets affects the potential energy of a magnet system. So again, we're going to be looking at strength of magnets and distance between the two magnets as our overarching concepts. Okay, to your notebook today, you need to add key concept number 7 and 8 to your key concepts page of your OneNote notebook. Okay, we are skipping key concept 6, so don't be looking for that one. It's not there. Okay, with that being said, key concept number 7 says that moving a magnet against a stronger magnetic force transfers more energy to the magnetic field. And 8, a magnetic force is stronger closer to a magnet. Okay, make sure you guys add those both to your vocab, and then go ahead and move on to your warm-up. There's 4 pages for your warm-up today. I'm going to do the first one with you, and then I'm going to release you guys to do the other 3 on your own. So for this one, we're going to need our draw tool. Okay, the very first step, it says, on each image, draw an arrow to show the direction that would indicate the magnets moving against their magnetic field. So let's review this really quick. If we are moving with their magnetic fields, we are moving with what the magnets want to do. So if they're attracting magnets, they want to move closer, so we're going to move the magnets closer. Okay? If they're repelling magnets, they want to move apart, so we're going to move them apart. That's going with their desires, if you will. Okay, moving against, on the other hand, which is going to be your main focus today, is going to be moving against or doing the opposite of what they want to do. So we're going against their wishes. So again, attracting magnets want to move close, so we're going to move them a little further apart and do the opposite of what they want to do. If we're looking at repelling magnets, they do not want to go together, so we're going to move them closer together. So in this question, it asks us to draw an arrow to show us, all right, if we were to take and move these 2 magnets against their magnetic field, which direction would I move them? Okay, this is a system of repelling magnets. They do not want to go together, so we're going to move them together. So I draw one little arrow to show I'm going to move this magnet closer to this magnet. Okay, this is also a repelling system, so I'm going to do the same thing. I'm going to move them closer together because that's the opposite of what they want to do. That's the first step. Okay, then you're going to compare these 2 magnets. They're both sets of strong magnets, but you guys can see that this system is set up closer than this system. So if we move this magnet 1 space over here, and we move this magnet 1 space over here, which do you think would have the most potential energy in that move? These 2 that are closer together, or these 2 that are further apart? Okay, if you guys said closer together, you are correct for our system of repelling magnets. Okay, so again, we're moving against, so if we remove them 1 against, okay, we would have more energy in this system. Okay, so I did the first one for you guys. You guys are going to do the next thing on your own, and this one we have the exact same setup on the last, except now we have attracting magnets. So our with or against is going to look different, our arrow is going to look different. Okay, and then you guys will circle which one you think will have the most potential energy in the system when we make that move. Okay. For the next slide, slide 5, you guys have same distance apart, but now you guys have a system of weak attracting magnets versus strong attracting magnets. And then slide 6, a system of strong attracting magnets, or excuse me, repelling magnets, and a system of weak repelling magnets. So again, show me the arrows to show me which way would be against the system. And then if we were to move that magnet 1 space with your arrow that you drew, which one's going to have more potential energy, the strong or the weak? Okay, pause this video, take a second, finish slides 3, 4, 5, and 6. I already did 3 for you, and when you're all done, we'll come back to this video. All right, so the next 2 parts of this, we're going to look at 2 different claims that kind of encompass our learning targets of how the strength of magnets affect the potential energy and then the distance between 2 magnets. The first claim we're going to look at is this second learning target about the distance. Okay, so let's read our 2 options for this claim. Claim 1A, Magnets closer together will have more potential energy stored in the system when we move them against our magnetic field. Or if we have two magnets that are set up further apart, magnets further apart will have more potential energy in the system when we move them against their magnetic field. So we're looking at magnets close together, moving them against their magnetic field, and magnets further apart, moving them against their magnetic field, which is going to have more potential energy stored up. Okay, so your directions to test all of these are on the next two slides, and your data table is on slide 10. Okay, the first thing you guys are going to test, your instructions are on slide 8, and that's going to give you data for 1A. So let's take a look at that. We're going to do kind of the first couple together, and then we can compare those a little bit. So place two strong magnets 4 grid lines apart so they are attracting. Record your initial potential energy. So here are my two strong magnets. We're going to have 4 grid lines in between them. So 1, 2, 3, 4. So 4 sets of dots in between. And then we want them to be attracting. So I'm going to flip this little guy here. And we're going to record our initial potential energy. So 6774.9. So we're going to go down to slide 10. Our initial potential energy, 6774.9. Okay. Then we are going to determine which way we're going to move our magnets. So let's go back up to our directions. Choose how many grid lines you will move one magnet. Whatever you choose for this one right here, you're going to want to do for all of these in the sim. So every place you collect data for the rest of this assignment, that's what you're going to use for your movement, okay? So I'm going to just choose 2. If you guys don't want to do 2, you're more than welcome to do something different, but then you're going to have to kind of regenerate your own data, and that's totally fine too. But I am going to do some of this for you guys. So I'm going to do 2 grid lines, then I'm going to move my magnet each time I move my magnet. And I'm going to record that in my data table. So every time I move, I'm going to do 2 grid lines. So I'm going to move my magnet either closer or further away 2 times, depending on my system, whether it's attracting or repelling. So I went ahead and filled out 2 in this. Okay. The other thing I can fill out in this data table is this column right here. This is the direction that we're going to move our magnets based on whether it's an attracting or repelling system. So remember, we're going to be moving against every time. Okay, so each one of these on all the sims, we're moving against our magnetic field. So attracting want to move together, so we're going to move them further apart. So I'm going to put in here further. Okay, repelling, they want to go apart, so we're going to move them closer. Okay, and then again, same here, attracting, still going to be further, and repelling, still going to be closer. Okay. So that's the first thing, is I kind of filled out that information. I didn't need to get that from the sim. Okay, I've got my initial potential energy recorded for my system of magnets that I set up in the sim, and now I'm actually going to move them. So again, these little guys want to move closer together. We're going to go against that, and we're going to move them 2 spaces away. 1, 2. I'm going to record my potential energy now. So 7001.2. Okay, and I'm going to record that under my final potential energy. So what we saw is when I made that move against the magnetic field, our potential energy went up. We want to see how much it went up by. Okay, so we're going to go ahead and use the calculator. If I look at my directions, here's a link to a calculator right here. I'm going to use my calculator to calculate that difference. So I'm going to take 7001.2, and I'm going to subtract my initial 6,774.9, so 6,774.9, and I'm going to find out my difference, 226.3. Okay, because this was an increase, I'm going to do that as a positive, so positive 226.3. If it were a decrease and my potential energy went down, I'm going to do a negative for that to show that it was a decrease in potential energy and that we've lost potential energy in that move. Okay, now what I'm going to do is go back up to my instructions, and it says repeat for the 2 repelling magnets. So I'm going to go ahead. I am going to flip my magnet back to a repelling system. I'm going to move them so there's 4 grid lines in between. I'm going to record my initial potential energy, 7561.8. So actually, I'm going to scratch that. I'm going to not have you guys, I'm not going to show you guys that one. You guys can go ahead, collect data for your repelling. I'm going to show you guys the directions on the next one. Okay, so this is to collect data for our ones that are further apart. So let's read the instructions really quick. Place 2 strong magnets 8 grid lines apart so they are attracting. Record the initial potential energy. So unlike the last one, we were 4. Now we're going to be 8. So I got 1, 2, 3, 4, 5, 6, 7, 8 apart. So I should be right here. And I'm going to go ahead and record 7,083.8, 7083.8. 7083.8. Okay. Oh, sorry, wrong one. 7083.8. There we go. Okay, so this is my attracting system that is further apart. And then I'm going to go ahead and move them against. So I'm going to move them 2 more away from each other. 7120.2. Okay, and then I'm going to go ahead and subtract that difference, 7120.2 minus my first value, which is 7083.8, and my difference is 36.4. So it was still an increase, so we're going to do a positive 36.4. Okay, so what you guys need to do then is collect data for your 2 repelling systems. So you guys will take and you guys will do a repelling system that's 4 apart. Okay, 1, 2, 3, 4, and then you guys will move it 2 closer, collect your final. And then you guys will do one that's 8 apart. And then you guys will move that 2 closer to get your initial and your final. You guys will calculate the difference in that. And then what you guys are going to do on the next part is do a little modeling. Go ahead, take a second. Finish your data table. I've already given you guys 2 columns, so all you guys have to do is your 2 systems of repelling magnets, and then we'll go ahead and talk about how to do the modeling on the next slide. So go ahead, pause, get that done, come back when you're ready. All right, so let's take a look at how to do these 2 sets of modeling that we have on slides 11 and 12. So if we look at this, this is going to be our repelling system right here. So when we use the modeling on this, we are going to look at modeling just our repelling systems of magnets. So this is closer together, further apart, 1A, 2A. So I'm going to go ahead and highlight this and tell you to use this data for this first modeling tool, okay? That's the data you guys collected on your own. I haven't done that for you. Okay, for the other one, we're going to use our attracting systems right here. So this is going to be what we see on slide 12. Okay, so right here. Okay, so let's take a look at this. This is our attracting system. This is the one that we moved 4 grid lines. This is 8 grid lines, and then we moved them both a little bit further apart, so against our system by 2 grid lines. So let's take a look at our energies and see what we came up with. So first of all, I want you to think of this. Just looking at my green data that I have here, okay, which one had higher values in general for our potential energy? Okay, if you said the data for 2A, you are correct. Okay, so that means we have more energy in our system when those 2 magnets are actually further apart for the attracting. Okay, repelling might not be the same. Okay, so further apart, we have more potential energy in our system for that attracting set of magnets. Okay, closer apart, or excuse me, closer together when we move them against, we have a little bit less potential energy each time we increase those. So we're going to want to model that on slide 12. Okay, so let's start with our system that had more potential energy. Okay, we don't want to, so this is where we had them 8 grid lines apart. So we want some room here because we know that when we move them 10 grid lines apart, that we're going to have more energy in the system. Not by a lot, it was only an increase of 36. So then when we model this, we're going to do just a little bit more. Okay, so however you guys kind of choose to represent this is kind of how I'm doing it. So basically what I see is this had some energy in it, then we moved them a little bit further apart, so now they're 10 grid lines apart. Okay, we had slightly more energy, so it was an increase in energy. Okay, 1A, we had less energy in that system. We only had 6,774 versus over 7,000 for our initial. Okay, so we had 4 grid lines apart for this one, and then we moved them 6 grid lines apart, so 2 against. So this is less, this system here is going to be less energy than this. So if we did 3 bars on here, maybe we only want to do like 2 on this one. Okay, so this shows that initially we had less energy, right, in this system. And when we moved them closer together, we did increase. We went from 6,774.9 to 7,001.2. Okay, so I am going to show a little bit, maybe a little bit bigger increase. We're about the same here. Okay, so I went from like 2 bars to 3 bars. This one I only went from 3 bars to a little bit more than 3 bars. But this kind of shows me that this system, 1A, had less energy. If I go back, I can kind of mark that and say, this one's actually lower in energy. This one has a higher potential energy. Okay? All right. So go ahead, take a second. You guys can look at the 2 purple bars. Okay, look at which system, the repelling that were closer together or the repelling that were further apart, which one had more potential energy in general for your initial, and then when we moved them, what did the move look like as far as how much it increased? Okay, and go ahead and model those right here on 1A and 2A. Show me the repelling systems. This is closer apart. 4 grid lines move closer to 2. This one was 8 grid lines move closer to 6. Which system had more energy, the 4 to 2 or the 8 to 6? And then how did that change when you guys actually move them against reflect, kind of like we did on this system here. When you guys have finished that, you can unpause this video, come back, and we will finish the next claim talking about strong and weak magnets. All right, so moving on to a different claim, our other part of our learning target talked about strong versus weak magnets and which system's going to have more potential energy there. This seems to be a lot more simple than what you guys just looked at, so I think you guys will have a little bit easier time on this. I'm not going to help you guys quite as much on this one. Okay, so let's take a look at our two claims. Claim 1B says that stronger magnets will have more potential energy stored in the system when we move them against, or claim 2B, weaker magnets will have more potential energy when we move them against. So this one, like I said, is just a little bit more simple. You guys are just comparing strong versus weak magnets. You guys only have one set of directions because you're going to be doing the same distance in between your magnets every time. Okay, so place 2 strong magnets 4 grid lines apart. So 2 strong magnets 4 grid lines apart. Okay, record your initial potential energy. We want this system to be attracting this time. So I'm going to go ahead and flip this guy so he's attracting. Okay, choose how many grid lines you will move. We've already kind of done that. We're going to stick with 2 for each of these. Okay, and same thing, we should know that when we have an attracting system of magnets, if we want to move them against, we're going to move them away or further from. And if we have a repelling system, they want to repel, so we're going to move them closer together. Okay, so that's going to be the same for each of these, further away and closer together for the repelling. Okay, and you're going to do the same thing. You're going to record your initial potential energy, which should look very familiar to you, 6774.9. And then we're going to move them 2 grid spaces closer together, which again, this should look familiar to you guys. Oops, sorry, I'm going away. Further away is 7001.2. So further away, 7001.2. And then my change, I believe, was, let me just look really quick, 226.3. So it's going to be the same as your guys' first table for just this one. Okay. Then you guys are going to go ahead. You're going to use the calculator to find the change, which we already did. You're going to repeat for 2 repelling strong magnets. So now we're going to start. We're going to do our repelling. Okay, and we have 2 strong magnets. We're going to collect our initial. We're going to move them 2 closer together. And then we're going to switch it up and we're going to repeat for 2 weak magnets, attracting and repelling. So now we're going to get rid of our strong magnets. We're going to use 2 attracting that are, again, 4 spaces apart. We don't want to change the distance. Okay, attracting, you're going to record your initial. And then you guys will move your attracting further apart and see what happens. And then you guys will do repelling. And you guys will move your repelling closer together. And you guys will record your potential energy. And then just like we did last time, once this data table is filled out, you guys are going to use your data to show me how these 2 different systems look. So you have these 2 pages of modeling. I'm just going to do a quick color code for you guys so you know where you're getting your data. So my first set is going to be 1B and 2B. So I'm going to go up here and say, all right, 1B is repelling. 2B is also repelling. Okay, but those are going to be your strong magnets here versus your weak magnets here. Okay, then you guys are going to compare on your data table is going to be your, which color haven't I used yet? Let's see here. Orange, sure. So then for this one, we're going to use our attracting, which we've done one of those with our weak attracting, and you're going to use that to do your slide 17 modeling. So again, like I said before, compare which system has more energy, your strong or your weak attracting. Okay, your strong or your weak repelling. And then those bars are going to have more. And then when we move them against, are we increasing or are we decreasing? Okay, so model that where you guys go from here. Are we increasing when we move them against or are we decreasing when we move them against? Reflect that in the bars you guys draw. Then your other system, whatever is your weaker system, go ahead and do the same thing. Show me what happens when we move them against. Okay, so go ahead, take a second, collect your data on slide 15, model that data on slide 16 and 17 based on how I color coordinated it, and then I will go ahead and explain the last little parts to you guys. All right, so moving on, you guys have this little challenge to do, and in class we collected this data to see who could get the most potential energy in their system. Okay, you guys are going to build 3 different launchers. I want you guys to build 3 regardless. You might have your very first one be your best, and you might think, yeah, this is the best it's going to get, okay, but you don't know that you can't get better. So I want you to try 3. Okay, if you get really good one the first time, see if you can do a little bit better for your second time. So remember that your launcher should be a repelling system. So in the sim, you guys are going to build 3 different launchers. Okay, you're going to collect data on them and tell me, all right, what's the most amount of potential energy that you saw in each of those 3 systems? Record your data in this table here. Then once you guys pick, go back and build whichever one is the biggest. You guys will screenshot that here. I want to be able to see your potential energy on there, so make sure you guys screenshot that with your potential energy. Okay, so build those 3 launchers, record your data for the maximum amount of potential energy, screenshot it. And then last but not least, you guys are moving on to this article read. So read Escaping a Black Hole. The article itself looks like this. It's only 3 paragraphs long. It's fairly short. It's really interesting, though. I don't know about you guys. Oh, excuse me, 4 paragraphs. It's very short. So read that, learn a little bit about black holes, which I think are pretty fascinating, and I'm not a huge space person myself. And then answer these 2 questions. Why do astronauts on the moon seem like they're walking on springs, like if they had big old springs attached to their boots and they're bouncing? Okay, while on Earth, we are firmly attached to the ground. And then why are black holes black? Okay, so answer those 2 questions. This is actually going to be extra credit for you guys. So if you do that, it's worth 2 points extra credit if you guys do a good job. And then when you're done, go ahead, do your wrap up. Do you have any questions? Yes or no? If you do, type them here. And then 4, 3, 2, 1. How do you think you did? Hope you guys are having a great day. Let me know if you have any questions, and I will talk to you soon. Bye.